Sorry, the screen was acting kind of crazy. All right. And so on this, we talked yesterday about inverses and logarithms. And so we're redoing this problem on page 30. All right. This has a low value of 2 and a high value of 3 is what you said. I asked you to do 2 and 3 here. And so how did you get that? Well, if I'm using this without a calculator right now, that's kind of where we would do this estimate. If I said 5 to the first power, what's 5 to the first power? 5. What's 5 to the second power?
25.
25. 5 times 5, or 5 squared is 25. All right. What's 5 to the third power?
Like 225 or something.
Not quite. You went a little too far.
125.
125. All right. 5 times 5 is 25. So pretend like you have 5 quarters. All right. And you got $1.25 is what you got. Okay. Now that's far enough because what am I trying to find?
45.
Trying to find 45. Okay. So 2 was the low estimate. 3 was the higher estimate. Would it be closer to 2 or closer to 3? Be closer to 2. All right. 45 is closer to 25 than it is to 125. Now, so what would be your guess if you made a guess? What would you say? 2 point what? 2.2, 2.3, maybe 2.4. All right. But that's probably about as far as I would go. I wouldn't probably guess any farther than that. I'd probably guess something like 2.3. All right. And then if we used our calculator, we used our calculator in 2 different ways yesterday. We took this and we graphed this. We graphed the left side, we graphed the right side, we found an intersection. Okay. Or we kind of did a shortcut in the calculator. Where was our log key on our calculator?
Next to 1.
Next to the 1. So if I go control and log, then we can say 5 is our base, and 45 is that piece that goes there. We're going to revisit this here in a second. And so if we do that, we got 2.365. So we were in pretty good shape as far as trying to guess that. Okay? So can you see where some of this could be non-calculator? All right, we could get to some of those answers, but then, yeah, there's a lot of times that we're going to need our calculator to help us with that. Okay? All right, so let's turn to page 29. I asked you to do a couple of problems on page 29. Let's take a look at those. All right, on page 29, we did this. I believe we did number 2 together yesterday. All right, and number 2, what we did, what do we do to solve for an exponent? How do we get rid of this 18 right there? We do the log of that base. Okay? We do the log of that base. So log of 18 is 18. There's an x there. We do the log of 18 on the other side. All right? What happened with this from yesterday?
Turned into 1.
Turned into 1. It canceled. It turned into 1. It gave me 1x. And what's that over there? Looks exactly the same, right? It's also 1. Okay? So we have a little property here. We did this yesterday. We have a little property that's unique that works for all numbers, really. If you have the base and the number right by it, if they are the same exact number, then that answer is always going to be 1. Okay? So you can have log base 5 of 5, log base 20 of 20, log base pi of pi. All right? Whatever you put there is always going to be 1. So that's a very common property of logs. Okay? Which it makes sense. If you were looking here, what exponent would you put in there? That makes sense. For 18 to get 18, you do 1. Okay? What answer did you get for number 1?
5.
X equals 5. All right? And because I would have done log base 2 of 2x there. And in my calculator, I would have put log base 2 of 32. That's how I got the 5. All right? How about number 3? What'd you get for number 3? -2. Good. And so on that one, again, log base 10 of 10x equals log base 10 of 100. All right. That gave me -2. What'd you get as an answer for number 4? 0. Anybody think that kind of weird? All right. How do I get an answer of 0 there? What's going on there? What property that you know of is this kind of holding up? The answer is 0. That is correct. anything that you take to the power of 0, so pick any number you want, raise it to the exponent of 0, it's always going to give me 1. Okay, so that's true. Doesn't matter what the base is. So if I had done this, I would have done log base 3 of 3, and I would have done log base 3 of 1, and this is what I put into my calculator, and that's what that gave me. All right, now here's a shortcut, or here's another property. I don't care what this is right there. If that is a 1, all right, doesn't matter what the base is. If that's a 1, the answer is always going to be 0. Okay, so that's another little property. Now, number 5. What'd you get on number 5? X equals
Negative 6.247.
4.7 or 4.8 or whatever, how you rounded, depending on how you round it or whatever. Okay. So there that is. Now, why did that work out evenly? Like everything else has worked out evenly. Let's talk about how we would do this one by hand. If you had to do this one by hand, 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. What am I doing?
Going up by 2.
I'm multiplying by 2 every time. I'm adding another 2, so I'm multiplying by another 2 every time. So this would be 16, then close. 32, then 68, then it starts getting big pretty quick because it's exponential. 64, excuse me. I was jumping ahead to 128. All right, 64, then 128. Now, you're going, well, why did you put that up there? Well, what number are we talking about? That number right there, all right? More particularly 176, but 76 is where I'm looking at. Where does 76 fall? Between 64 and 128. So it's going to fall between 6 and 7, and it does. All right? Now, what's weird about that negative? I've got a negative here. All right? Look at the 5 problems that I asked you to do. Look at the ones that were negative. See if you can make a connection there. They're fractions. Okay? So where's this 76? Yeah, it's 76, but that 76 is where? In the bottom. It's in the denominator. All right? So this is a fraction. So whenever we have fractions, we're getting negative exponents there. All right? Same thing over here. This one right here, to tell you the truth, number 3, if I was going to do this one by hand, I don't think of this as being 100. I think of it as being 100. How many 10s does it take to get 100? 10 times 10, 2 of them. All right? So 10 squared is that, but it's a fraction, so it's negative 2. All right? So here's what I want you to do. I'm going to give you a little time. I want you to go complete that page. Some of you already did. All right? I want you to write out what you have, though. Make sure that you're writing there. If I ask you to, show your work, what work is it that I need you to show? Need you to show that. So show your work and go do 6, 7, and 8. All right? We'll come back together here in a second. All right? So same page, page 29, go do 6, 7, and 8.
Intentionally, and I don't make you sex. I'm gonna make you go pick it up. You gotta pick it up.
I'm already.
How would you do that? You have 2 grades. Yeah.
Did you get 3.98? What's it telling you? Yeah, but what is it? Yeah, but it's just off by just a little bit, it's just around here. That's right, yeah. Just make sure that you're showing your work too, you know what I'm saying? I know how much you love that.
Oh, it says air.
Yeah.
It's an imaginary one.
Mm-hmm.
No solution. Cause if we bracket too, it could cost, could be more costly thing. So,
All right, so let's talk about these real quick. Had a little bit of time to work. All right, so 6, 7, and 8. What did you get on number 6? X equals what?
I got
3.988.
3.988.
Okay, what around that? Oh, 3.99. Okay, which is really close to what?
4.
Really close to
81.
4. All right, and so again, we did the log of 3 on this side, and we did the log of 3 on this side. So this is what we put in the calculator. All right, could I have gotten pretty close by doing this by hand?
Yep.
What's 3 to the first?
3.
3. What's 3 squared?
9.
9. What's 3 cubed?
81.
You skipped one.
27.
27. All right. 3 times 3 is 9, times another 3 is 27, and then 3 to the 4th power is
81.
81. Did you do that by going 27 times 3?
Something like that.
It's 9 times, it's a bunch of 9. So this 3 to the 4th, it's 3 times 3 times 3. A lot of people are just multiply 27 and have to multiply by 3 again. I don't like that. I do 3 and 3, which those are both 9s, and then 9 and 9 is 81, because that's just easier math for me. All right?
It goes over 80.
Now, so here's the deal. If it's exactly 81, then it would be 4. But am I 81? No, but I'm really close, right? And so what is my exponent? Well, it's really close to the 4 that it should be there. So you can see how we can do this by hand. We can get some pretty good, but to get exact, a lot of times we need assistance from our calculator, all right? How about this one? How about number 7? What'd you get? 2.98, all right? Did we see this a while ago and kind of the problem that we did? We did 5 to the first was 5, 5 to the second is 25, and 5 cubed is
125.
125, which is really close to that, all right? So my answer should be really close to 3, but not quite 3, okay? All right, so now let's discuss the one that everyone was talking about when I was walking around. What did you get here? It gave me error. The calculator said error. It said I can't do it. All right. So what's going on here? The answer is no solution. There is not an answer here. You can do that, or you could use your symbol.
Yeah, I would.
Okay.
Yeah, but you asked me.
But
You asked me to say, hey, wake me up when I'm
can you tell me? Can somebody give me a reason why this doesn't work? Not just because the calculator told me so.
Because 36,
because-
like the square root of 36 is 6,
Okay.
but you can't, there's no way to get a square root of
Okay.
negative 36.
So you're talking about some square roots now. Be careful, it's a little bit different, but I see what you're doing there, all right? There's another reason I'm kind of looking for. How else could you prove that this doesn't work?
You can't multiply a number by itself and get a negative.
Okay, you can't multiply a number by itself and get a negative, so that's good. And I think that's kind of what you were going after a little bit. So, but it's just 2 of them, right? What if I had 3 of them? What if I had 3 negatives?
That'd be okay, right?
Then that would maybe be okay, right? So I gotta be careful on that one. What did we do yesterday? Before we built all this, what did we do with this side right here? We graphed that. So we said y equals 60x there. We graphed that side right there. So let's do a quick little sketch, all right? What does this graph look like right here?
Exponential.
It's exponential. So it's here and it's there. All right? Tell me about the y values of that graph.
Never touched 0.
and never touch zero. Remember we talked about an asymptote, we were talking about modeling here? All this is above the x-axis and never is a negative number. Well, what am I telling it to be here? I'm telling it to be a negative. How would I represent negative 36 on the graph? A negative horizontal line at negative 36, okay? And then, well, the second part we did yesterday is we found the intersection of those two. Guess what? They don't, right? So therefore, what's the solution? Where do they cross? Well, it doesn't, okay? All right? And so that's kind of one way I can prove that as we're going. Now, many of you, when I asked you to show your work, and this is fine, this is good, all right? Many of you weren't showing me this side over here. You just had already made the pattern, right? Because you said 3 is my base there, 3 is my base there, and so I'm going and jumping to it and I can go, all right? Which that's fine. So we need to be able to convert from one form to the next. So what I've done is I've given you these in exponential, and what you've been doing is you've been changing to the log form to solve it. So if this changed it to the log form, we could do it the long way, which I've been doing. Multiply by log of base 3 on both sides and simplify. Or a lot of you have been noticing the pattern is if we do log, we keep the base, which is 3, the 9 goes over there, and x goes over there. All right, so we could change from exponential to log. All right, by the way, what's the purpose of a log?
Find the amount of,
To find the missing what?
or define what it is to the power of.
Okay, to find the missing power or the missing exponent, all right? So logarithms were kind of invented so that we could find the missing exponent. So the answer to a logarithm is the exponent, all right? The missing exponent. So that's what we've been doing, all right? Now, need to be able to go the other way as well. So what if I were to give you that? Okay? So if I give you a logarithm, can we write it in exponential form? Now, if it's me, if they give me a logarithm like that, a lot of times I'm going to go in and set it equal to x just so I have that answer, all right? Now, here's what's taking place. I could solve this if I know a little bit about this. The log is the missing exponent. It's a missing exponent that takes 3 and makes 81, all right? We did that a little bit while ago, all right? But if I'm going to change this to exponential form, this 3 is going to stay. The x is my exponent, and the 81 is what I'm trying to get it to equal, all right? So this logarithm right there, if I want to write it in exponential form, that's how it looks like, okay? So we can answer it just as it is, all right? Or we can write it in that form. So here's what I want you to do. Turn back to page 27. So go backwards to page 27 in your book. So on this one, it's going to ask me to do 3 things on these problems. It's going to ask me to write the exponential equation, all right? Then it's going to ask me to determine the value of the exponential or the logarithmic expression, and then show how you got your answer. If there's not a rational, explain how you determine an approximate value, all right? So here's I'm going to kind of change the rules a little bit on you. I'm going to do number 1 with you, all right? So again, the answer to a log is the missing exponent, okay? So how many 10s does it take to get to 100? Okay, 10 times another 10, so it takes 2 10s. 10 times 10 is 100, there's 2 10s. So the exponent is 2. So the answer to this problem, if I make that x is equal to 2. All right? Now, that's the second part that I found that answer, but what it wanted me to do is it wants me to write this in exponential form. So 10 is my base, that x is my missing exponent, and 100 would be that value. So I want you to write the exponential equation, right? I want you to solve it. Try to solve it without a calculator, and then go back and plug it in the calculator and see if you got the answer correct. Now, the first 4 or 5, you can do without a calculator, but then when you get lower on the page, you're going to need a calculator to solve it, all right? So I'm going to give you some time. You're working on the rest of the page. You're working 2 through 8, all right? And you're changing the exponential, solving it, and then use your calculator to check. sense?
Yeah.
This one, or, well, what X bar is always gonna be 0? I need that. Is that part down here? It's not too, it's, there's so many for it, but they're equal at the same time. Good. And here's what I would do, okay? 6, you give me 36. Alright, 6, what power you give me 6?
Wait, I think I'm doing this wrong.
6 times 6, 6 squared. But it's not 36, it's a fraction. So remember what we said about every time we have a fraction, we have to do that. That's fine. So, that's right. So 6 squared is 36, so that's 2. But it's a fraction, it's okay. That make sense?
Alright, I think I'm doing this wrong.
Did I explain it right?
Hey, Coach Riss, I think I misunderstood what the directions were.
I'm up.
Oh, I'm hurt. I'm hurt.
Write the exponential equation there, and then so I'm just like in the calculator.
Alright. So what, that's.
It's 0. This is 0?
Yeah, okay.
That's 0.
When I put it in.
So, 0. Good? So,
Oh, never, yeah.
I'm just gonna walk around looking at that. Any number of times. This is gonna be our homework or whatever, because I'm gonna go over something. We'll go over that test